My name is Álvaro. I'm a full stack developer and I'm mainly focused on the Suntrack services web platform. And today's presentation is about the Suntrack monitoring. It's split in mostly two parts. The first part is about the problem of the monitoring itself. It's a bit of a heavier part. And the second one is what the Suntrack Services portal is offering to our customers. We will start by talking about two topics here that I think they are important to understand. One of them is the scale of the data, because we are working with high volumes of data, and we need to provide real-time access for those high volumes of data, and also we need to provide long-time archival data availability, because we are working with data that goes back to 2018, for example. And to understand a little bit about the size of the data lake that we are working, we are receiving 2.8 million files a day, and our data lake is roughly, I believe, 25 terabytes of data. And the second topic on this is the scaling. Well, the scaling is a little bit important because every week we have new solar plants, and this system doesn't need someone to be there scaling the servers, adding more servers, or making the servers bigger. So it basically needs to auto-scale. I'm going to talk about the field ecosystem, which is basically what we have built there. Imagine this as a tree. As the leaves of the tree, we would have the TCU, which is mainly responsible for telling the panel where to face. The RSU, which is mostly provides weather data, and the NCU, which acts as a concentrator of the TCU and RSU. Both of them are connected to the NCU, and the NCU is connected to the cloud. Well, basically, in fact, the diagram is not that simple, because under an NCU we would have up to 200 TCUs, and in between the NCU and the cloud we will have an industrial PC, which is actually doing the connection to the internet. And under the data logger, we will have several NCUs, as many as your solar field has. But to keep things simple, we will leave it like this. So, in summary, we will have the TCU. The TCU generates a file. That file goes over here, and then the file goes to the cloud. So, at the cloud level, we will have to deal with a problem that we didn't mention before, which are internet outages. Internet outages are a little bit of a problem, because when a solar plant loses internet connection, we at the field doesn't lose that data. We simply save them locally, and once the installation recovers internet connection, it will try to push them all at the same time. You see this chart, which represents the load of the ingestion. You see those spikes. Well, those spikes surely represent installation recovering the internet and pushing lots and lots of data at the same time. So, to deal with this, we are using Amazon Web Services, and mostly three services are related to these topics. The first of them is S3. It's an object storage, in which you can place as many files as you want, and it basically acts as a very reliable ingestion layer, because it has very high durability. Also, we will have Lambda, which is the functions as a service of AWS, and it basically is pay for computing. We use Lambda for checking for malformed data, that maybe if a solar field has a wrong configuration, it will start emitting malformed monitoring data, and it's important to fix this as soon as possible, because if after several months you realize that the data is not correct, it's months of garbage data. And also we have SQS, which is basically a queue system that we are using in combination with AWS Lambda. And it basically stores every failed execution with of the Lambda. So this was a bit of the heavy part of the presentation. The last part is about what the Suntrack Services portal is actually offering to our customers, and the entry point of the monitoring platform is this map, where we represent the installations in bubbles, mostly in green, yellow, and red bubbles, in order to represent more or less the health of the installation. And by entering one installation, we see now the detail of the installation, and each bubble now represents the NCU. And if we enter an NCU, actually in this image we are seeing the devices of several NCUs at the same time. We can see the markers for every TCU, and those markers represent with colors the operational status and the communication of status of the TCUs. And also you can see how the marker is being rotated in order to represent where the marker is, where the panel is facing, in order to see if there is a panel that is not following the rest of the panels and that kind. So we are also representing the RSU in these other markers, and under the RSU you see the unit stage, for example. So by checking this map, you could try to figure out if there is something wrong with your installation, but checking this page every day, it wouldn't be the great idea, because we are also offering the Suntrack Guardian, which is a real-time analysis tool that is always looking for anomalies in the monitoring. So, for example, apart from the typical alarms that we would find on the monitoring data, such as low battery, or even you might leave an emergency button pressed, we are basically comparing variables. For example, the easiest one to understand is the ideal position of the tracker and the real position of the tracker. Well, if these two variables differ too much, it might be an anomaly. For example, if the backtracking is enabled, we will try to ignore this anomaly, but that's it. So another example of this is the temperature. For example, the temperature between the PCB and the battery, because it wouldn't be very normal if the PCB is at 20 degrees Celsius and the battery is 40 degrees Celsius. That doesn't seem reasonable, so that we would consider that another anomaly. And there are other anomalies that are more focused on preventing a real failure, which are, for example, overcurrents. Overcurrent is not a failure by itself, but it could lead to a blocked axis. So, well, that was, in a short explanation, what the Suntrack Services web platform offers in relation with the monitoring. But some of our customers came with other use cases that are not covered with in the platform, and for those we have the monitoring replication, because some of them were thinking about, well, okay, I can build my own data logger I can try to interrogate via Zigbee protocol the TCU, extract that data, push that data to the cloud, run all my analysis. That's not necessary at all, because it's very easy for us to have the information that we are receiving. You can see when we receive a file, simply push that file to the client. It's not something difficult for us. We simply replicate the data, and the customer is now free to operate with this data. And this last part is important, because the client is now the owner of the data. It can do with that data whatever he wants. It's basically the same that we are receiving, and it's mostly real time. Maybe if you are in USA and we are in Europe, it could take some seconds, but it's mostly real time. And any operation that you do with this information has no side effects over the Suntrack services platform. So okay, I guess that's it. Thank you.